Working of a diode. As we know that p-type material consists of a large number of holes and few thermally generated electrons. Thus the holes are majority charged carrier in p-type of material. Similarly, n-type material consists of a large number of electrons and few thermally generated holes, and therefore in n-type material electrons are majority charge carrier. When a p-type semiconductor and an n-type semiconductor are joined together with the help of a special fabrication technique, a p-n junction is formed. Metallic terminals are connected with the substrates. The terminal of p substrate is called as anode and the terminal of n substrate is cathode. This forms the basic semiconductor device called diode. Now we can see that on one side of junction there is high concentration of holes, or we can say high concentration of positive charge. Similarly, on the other side there is high concentration of electrons, that is negative charge. This separation of charges forms a potential gradient across the junction and a process of diffusion get started. As n region has high concentration of electrons, some electrons from this region gets attracted towards p region. The free electrons from n region diffuse into p region and combine with holes present there. Every time electron of n region combine with hole of p region will leave behind a positive immobile ion on the n side. Similarly, the holes of p region get attracted with n region, diffuse with atoms of n region will leave behind a negative immobile ion. Because of this process, a large number of immobile negative ions will accumulate on p side near the junction, and similarly positive ions on n side near the junction. After the depletion region achieve a moderate width, it starts repelling the electrons to diffuse into the p side. Therefore, diffusion stops completely. At this point, the junction is said to have attained an equilibrium. Operation of diode. In the condition of forward bias, due to the negative terminal of external source connected to n region, free electrons are pushed towards the p side. Similarly, the positive terminal of supply will push holes from p side to n side. As the external supply voltage increases, more and more number of electrons and holes starts traveling towards junction. The electrons will start combining with positive ion of depletion region and convert it into neutral atom. Similarly, holes of p region enters into depletion region and combine with negative ions and neutralize them. As a result, the width of this depletion layer will reduce. The potential of this barrier will also reduce due to reduction in the width of depletion region. Now, there is absolutely no opposition offered to the flow of electrons and holes. Hence, this will give independence to a large number of holes and electrons to cross the junction under the influence of externally connected DC voltage. This leads to flow of current from cathode to anode known as forward current. As there is no opposition offered to this current and the forward resistance of diode is very small, typically it is the order of few ohms, that is 10 to 100 ohm. Due to this small forward resistance, there is a small drop in potential from one end to another known as forward voltage drop, which is equal to 0.7 volt for silicon diode and 0.3 volt for germanium diode. So, we have discussed the working of diode in forward biased condition. We hope now you have little bit idea about how a diode works in forward biased condition. In our next video, we will discuss the working of diode in reverse biased condition. Thank you.